Hello. In the last video, we talked about the 10 functions of insulin. Now, after we talk about 10 functions of insulin, we will talk about the control of insulin secretion here. As you can see in this figure, insulin is secreted by the beta cells in the pancreatic islet or islet of Langerhans. And when we have high blood glucose level, then of course it will stimulate the beta cell to secrete insulin. And just a review, insulin, the function of insulin is to decrease blood glucose level. So it will convert glucose into glycogen. And then if we have a lot of amino acid in the blood, it will also stimulate the secretion of insulin. Remember, one of the 10 functions of insulin is also converting amino acid into protein. And then we have GLP and GIP. GLP and GIP, we talk about GIP in the digestive system. At the end of the digestive system, GIP is one of the 4 gastric hormones. So GIP is one of the 4 gastric hormones at the end of the digestive system lectures. And GIP stands for glucose-dependent insulinotropic peptide. Glucose-dependent insulinotropic peptide. And GLP-1 stands for Glucagon-like peptide 1. Glucagon-like peptide 1. Glucagon-like peptide 1. And then, of course, when you have a sympathetic nervous system activated and secreting also the adrenaline epinephrine, these will actually inhibit the secretion of beta cell, inhibit the secretion of insulin. The reason is that when you are under sympathetic nervous system, you are in dangerous situation, fight or flight. Then that means you need more glucose to provide you energy to escape the danger or fight the danger. So because of that, you don't want insulin, because insulin converts glucose into glycogens. Insulin decreases the blood glucose level. And under sympathetic nervous system, you want to increase the blood glucose level. On the opposite, on the other hand, parasympathetic nervous system will trigger the secretion of insulin. And then after we talk about insulin, of course, it is the most logical for us to talk about the antagonist. Which one is the antagonist of insulin? Well, let's try to think about it first. Which one is the antagonist of insulin? Oops. Yes, it will be glucagon. Yes, because glucagon has the opposite effect of glucose. So let's take a look. If we have a low blood glucose level, with low blood glucose level, what will happen? The alpha cell, okay, alpha cell secrete glucagon, beta cell secrete glucose. This is something that we covered during the endocrine system. Hope you still remember. The alpha cell will secrete glucagon, so that glucagon can tell the liver to do glycogenolysis. What is that? During the post-absorptive state video, we talk about glycogenolysis. Glycogen, lysis, breakdown. Glycogen is glycogen. Lysis means breakdown. That means it's a process of breaking down glycogen. Glucagon will tell liver to increase the breakdown of glycogen. And then you will tell liver to increase gluconeogenesis. Neo means neogenesis, making, creating glucose. Creating glucose from new molecules such as fatty acid, amino acid, lactic acid, and so on and so forth. And then you also tell liver to increase ketone synthesis. Remember ketone, where do we get ketone from? When we metabolize fatty acid, such as, remember in the first exam I talked about weight loss and also the Atkins diet. Weight loss diet plan or Atkins diet basically give people the dietary recipe. It doesn't have any carbohydrate. People only consume protein and fat, so that it forces your body to break down body fat into glycerol and fatty acid. And then conversion of fatty acid into energy will produce ketone as a byproduct, and ketone will be excreted in the urine. And so increasing ketone synthesis, meaning that breaking down more of the body fat. So, and then after this, you will have more glucose and more ketone in the blood. And for this, you have a negative feedback, because after you have enough glucose in your blood, then you can stop secreting the glucagon. And remember that glycogen, where do we store glycogen? First place, liver. Of course, liver store a lot of glycogen, and then muscle also store a lot of glycogen. And then what else? We talk about kidneys. Yes, we talk about kidneys. We mentioned about kidneys storing glycogen in the urinary system lecture. In the urinary system lecture, kidneys store glycogen. So in these three places, and the interesting or unique things about glucagon is that glucagon has no effect on the proteins or glycogen in the skeletal muscle. So glucagon has no effect. Glucagon will not break down the glycogen stored in the skeletal muscle. It will only tell the liver to break down the liver. You may call it hepatic glycogen. It may tell the liver to break down hepatic glycogen. What the one in the muscle? Since we talk about low blood glucose level, then you have a glucagon. Then we will talk about other responses. So in addition to secreting a glucagon to help to restore the blood glucose level, what else can our body do to restore the so-called homeostasis, the optimal blood glucose level? It will, the low blood glucose level will be detected by adrenal medulla. So the adrenal medulla will secrete epinephrine, or you may call it adrenaline. epinephrine will stimulate the skeletal muscle to tell the skeletal muscle to increase the glycogenolysis. So you can see that epinephrine can break down glycogen in the skeletal muscle. When glycogen in the skeletal muscle is broken down, then you will increase the blood glucose level. And epinephrine can also have this effect. It can tell the liver to increase glycogenolysis, again breaking down the hepatic glycogen, and also increase the gluconeogenesis. Same reason, to increase the blood glucose level. And last but not least, it will tell the adipose tissue, the fat tissue, to increase lipolysis, is to break down lipid so that you can use fatty acid to increase fatty acid. Fatty acid, you can use it as a direct fuel to produce energy, or you can go back to liver so the liver can do gluconeogenesis to make more the glycerol. The glycerol can go back to liver to go through gluconeogenesis. And then the other pathway is here, increase sympathetic activity, so that the basically it's directly. This is the ANS, nervous system pathway. This one is the endocrine pathway. So that's the differences. The nervous system ANS pathway, the sympathetic nervous system can directly tell liver and adipose tissue to do all this. The endocrine system pathway will have to secrete epinephrine in order to do this. So these are the compensatory mechanism for restoring optimal blood glucose level. So we see that adrenal medulla secrete epinephrine or norepinephrine. What about adrenal cortex? How many of you still remember adrenal cortex? What kind of hormone you secrete? Well, in the next video we'll talk about that. Let's think about it now.